Hey coders, how's it going? Mohammed here, back again. Now, we have previously learned about different kinds of sequences in Python, such as lists and strings. We've also learned how we can access individual items from a list and individual characters from a string. Now, in this lesson, we'll be learning about slicing, which is a way of accessing a portion or a subset of a sequence. So by using slicing, we can access a portion of a list or a portion of a string. Over the next few videos, we will see slicing in action and understand how we can use it in our code. So I'll see you all in the next video. Slicing works by using indexing. So first we specify a start index, and this is where the slice will begin. Then we specify an end index, and this is where the slice will end. And all elements in between the start index and the end index will all be included in the slice. And this is how we're able to access a portion of the elements from a sequence. First, I'll create a comment, and let's go over the syntax of slicing. So first, you want to start off with the sequence. Next, you want to have an open and close bracket. And inside this open and close bracket, you can specify up to 3 arguments, and this will indicate how you want to slice the sequence. So the first argument is start, the second argument is end, and the third argument is step. So let's go ahead and detail each one of these arguments and how they work. So let's start off with start. Let's go ahead and create a docstring. So start is the index of the first element to include in the slice. Let's go ahead and jot this down. So start is the index of the first element to include in the slice. Now note that start is inclusive, so the items specified at this index will be included in the final slice. So this argument is inclusive. Let's actually wrap this around. So this argument is inclusive, and the items specified at this index will be included in the final slice. It's also important to note that the start argument is optional, and if you don't include it, it will default to 0. So this is an optional argument and defaults to 0 if you omit it. Next, let's talk about the end argument. So I'll create another docstring. And n is the index of the last element to include in the slice. Let's go ahead and jot this down. So n is the index of the last element to include in the slice. N is exclusive. So what that means is that the items specified at this index will not be included in the final slice. So this argument is exclusive, and the items specified at this index will not be included in the final slice. N is also optional, and if you don't include it, it will default to the length of the sequence. So this is an optional argument and defaults to the length of the sequence. And that's essentially taking the length of the sequence. And I realized I misspelled inclusive, so let's fix that. So as you can see, start is inclusive. The items specified at the index start will be included in the slice, but the item specified at the end index will not be included in the slice. So let's go ahead and discuss the step argument. So let's create a docstring. So the step argument is the number of elements to skip between each selected element. For example, we can use step to get every second element, every third element, or every fourth element from the specified subset. So let's go ahead and jot this down. So it's the number of elements to skip between each selected element. And for example, we can use step to get every second element or every third element from the specified subset. And this argument is optional, and it defaults to 1 if omitted. So one thing to note about step is that if we omit it and it defaults to 1, this means that consecutive elements in the specified subset will be included in the resulting slice. So no elements will be skipped. So as you can see, the start and end arguments represent indexes. So we can use zero-based indexing, negative indexing, or a combination of both to access a slice of elements from a sequence. And as a reminder, the best time to use negative indexing is any time you want to access the x to the last item from a sequence. So for example, if you wanted to access the third to last item, the second to last item, or the fifth to last item, negative indexing would be a good choice. And similarly, the best time to use zero-based indexing is any time you want to access the X item in a sequence. So for example, if you want to access the second item, the third item, or the fourth item, zero-based indexing would be a good choice. So that essentially wraps up slicing. So let's go ahead and head over to the next couple of videos and we'll see slicing in action with lists and strings. So we're going to finally see slicing in action. So let's recall the slicing syntax. So first we have our sequence, then we have our open and close bracket, and in between these brackets, we can specify up to 3 arguments. We can specify start, end, and step. So let's go over each one of these arguments. Start is the index at which the slice starts. Start is inclusive, which means that the element that's located at the start index will be included in the final slice. Start is also optional, and if omitted, defaults to 0. Next, we have stop, and stop is just another way to say end. These terms are interchangeable. So if you hear me say end, or if you hear me say stop, know that they mean the same thing. So stop is the index at which the slice ends. Stop is exclusive, which means that the element that's located at the stop index will not be included in the final slice. Stop is also optional, and if omitted, defaults to the length of the sequence. Next, we have step, and step is the number of elements to skip between each selected element. Step is also optional, and if omitted, defaults to 1. So let's go ahead and create a list of fruits. And here we have 2 comments. The first comment details all of the zero-based indexes, and the second comment details all of the negative indexes. So using slicing, let's go ahead and get a portion of this list. Or another way we can say this is let's get a subset of this list. So let's say in this subset, we want to include apple, banana, orange, and grape. So let's go ahead and actually create a comment. and it will say go of the subset. And we'll go ahead and paste the subset that we know that we want to get. So let's go ahead and write out this expression. So we'll start off with our sequence. In this case, it's a list of fruits. We'll go ahead and have our brackets. And we want to start off at the index 0. And we want to end the slice at index 4. And in this case, we're not going to include a step. So we're only going to have start and end. And we know that start is inclusive. So whatever element is at the start index will be included in the final slice. So here we have 0, and we see that apple is at 0, and we want apple in our final slice. Next, for n, we chose 4, and we know that n is exclusive. So whatever element is at that index, in this case mango, this will not be included in the final slice. And this is exactly what we want. We start off at 0, we go up to the end index, but we don't include the element that's at the end index. So let's go ahead and print this out. And I'll include a string so we can see that in the output as well. And let's go ahead and run this. And as you can see, we have apple, banana, orange, and grape, just as we wanted. So recall that the start index is optional. And if we don't include it, it'll automatically default to 0. So we could actually rewrite this statement and not include the start index. And this is how it would look. So let's go ahead and run this. And as you can see, when we don't include the start index, we still get the exact same subset. We have apple, banana, orange, and grape, just as we saw before. So let's go ahead and go over another example. So in this example, let's say we want a subset that contains banana, orange, grape, and mango. So starting from banana, we pretty much want all of the elements in the rest of the list. So let's go ahead and create our slicing expression. So we'll start off with list of fruits. We'll have our open and close bracket. And since we know we want banana to be included in the slice, then we're going to go ahead and make start 1, since banana is at the first index. And since we know that we want the remaining of the elements in the list, then we can go ahead and use the length of list of fruits as the end index. So let's go ahead and create a variable called length, and we'll assign it to the length of list of fruits. And we know that length is 5. So we're basically just putting 5 here. And so because 5 is the end index, that is going to allow us to include mango in the final slice, because we know that the way slicing works is it starts at the start index, it goes up to, but does not include the end index. And since the end index in this case is 5, that means that we are going to include index 4, 3, and 2. So let's go ahead and print this out. Let's also include a string. And let's go ahead and run this. And as you can see, we have banana, orange, grape, and mango. Another way that we could rewrite this is by completely omitting the end index, because we know that the end argument is optional. And if we don't include it, by default, it is going to default to the value of the length of the list of fruits. So we actually don't even need to do this computation here. So let's go ahead and remove length and remove it from here as well. And let's go ahead and run this. And as you can see, we have the exact same list. We have banana, orange, grape, and mango. So let's go over another example where our slice actually contains all of the elements from the list. So let's go ahead and create our slicing expression. And since we know that we want all of the items, we know that we want to include apple in the final slice. So we'll use 0 for start. And since we know that we want to include the rest of the items in this list, we can actually just omit the end index. So let's go ahead and print this out. And then we can run this. And as you can see, we get apple, banana, orange, grape, and mango. So we get back the entire list. And we could actually even rewrite this to completely omit the start index, because we know that if we don't include the start index, it's going to default to 0. So essentially, omitting the start and end index will give us back the entire list. So let's go ahead and run this. And as you can see, that's exactly what we get. We get back a list that contains apple, banana, orange, grape, and mango. And let's actually leave some comments here just so we know what each slice is doing. So we'll say goal of the subset. And we know that starting from 0, we're going all the way to the end. So this will be the entire list. And similarly here, we'll do the same thing. So we'll leave a comment, goal of the subset. And we know that we're starting from banana and we're going all the way to the end of the list. So let's go over another example. And let's say the goal of this subset is to grab banana and orange. So let's go ahead and write a comment. So let's create a slicing expression so we can grab banana and orange. So we see that banana is at index 1. So we'll make start 1. We'll have our colon. And then we know that we also want orange. And we see that orange is at index 2. So that means we should use index 3 as our end index. And that will allow us to get banana and orange, because the element at index 3 is not going to be included in the final slice. So let's go ahead and run this. And as you can see, we get banana and orange. Let's go over another example. Let's go ahead and create a comment. And let's say for this subset, we want to get a subset that contains orange and grape. So let's go ahead and add that here. Let's create our slicing expression. So we know we want orange, and we can see that orange is at index 2. So we'll start at index 2, and we know we also want grape. So if we want grape, and we know that grape is at index 3, then we should use index 4. So let's go ahead and add that. And let's run our code. So add a print statement here. Let's also add a message. And as you can see, we have orange and grape. So we've gone over a few examples using zero-based indexing to slice this list. Now let's see some examples using negative indexing. So let's see that in action. So let's go ahead and do the same thing as we did before. the goal will be to get a subset that contains orange and grape. So I have a list of fruits. And let's go ahead and see what index we should use so we can start at orange. So here we see that orange is located at the negative third index. So we can use -3 as start. We'll have our colon. And let's go ahead and see what index we can use for grape. So we see grape is located at the -2 index. So if we want to include grape in the final slice, then we should use the -1 index. So let's go ahead and add that. Next, let's go ahead and print this out. And let's run this. As you can see, we have orange and grape. Let's go over another example. And let's actually do this one here. So the goal of this subset is to get banana and orange. So let's create a slicing expression. Now we can see banana is located at -4. So we can use -4 as the start index. We can have our colon. And to get orange, we see orange is at the -3 index. So if we want orange to be included in the final slice, then we should use -2 as the end index. So let's go ahead and print this out. And let's run our code. As you can see, we get banana and orange. Let's also do this example from earlier. So the goal will be to get a subset that contains banana, orange, grape, and mango. So we'll create our slicing expression. And we see that banana is at the -4th index. So we can use -4 as start. And we know we want mango to be included in the slice. And we see that mango is at -1 index. But we also know that if you want to obtain the rest of the elements from a list, then we can go ahead and just omit the end index. So we can just leave it as is. So let's go ahead and print this out. Let's run this. And as you can see, we get banana, orange, grape, and mango. Let's go over another example where we use a combination of zero-based indexing and negative indexing to create a slice of elements. So let's say our goal of this subset will be to get banana, orange, and grape. Let's go ahead and add that here. Let's create our slicing expression. So if we want banana, we see that this is at -4 and at the first index. So we can actually choose either one. So in this case, I'll go ahead and choose 1. And we see that we want grape to also be included in the final slice. And we see grape is at the 3rd index and the -2nd index. So since we've already chosen a positive index, let's go ahead and choose a negative index for end. So here we see grape ends at -2. So if we want grape to be included in the final slice, then we should use -1 to be end. So let's go ahead and add -1. Let's go ahead and print this out. And then we can go ahead and run this. So as you can see, we get banana, orange, and grape. So throughout these examples, we have been omitting the step argument, which defaults to 1. So let's see some examples on how the step argument works. So let's go ahead and create a subset, and this subset will give us the entire list. So similar to here, we've done this before, so I'll just copy this and paste it down here. And we can go ahead and omit the start index and the end index. And this time, let's include a step of 2. So let's go ahead and run this. So here we can see we get back apple, orange, and mango. So let's compare to our original list of fruits. And we can see that banana and grape were skipped. And this is because this is how the step argument works. It specifies the number of elements to skip between each selected element. So in our case, because we specified a step of 2, we are going to be choosing every second element from list of fruits. So because we specified in our subset that we wanted the entire list, we are going to be choosing every second element. So first we take apple, we skip banana and take orange, then we take mango. So similarly, if we chose a step of 3, then we would take every third element. And if we chose a step of 4, then we would take every fourth element, so on and so forth. So let's go ahead and actually do another example where we choose a step of 3. So let's go ahead and run this. And we get apple and grape. So now because we chose a step of 3, we're getting every third element. So we start with apple, and then we go ahead and get grape. And since there aren't any more elements where we can get the next third, we essentially stop at grape. So that's essentially how the step argument works. And that basically wraps up how slicing works with lists. We can use slicing to get a subset of any kind of list in Python, such as a list of strings, or a list of integers, or even a list of booleans. So let's see slicing in action with strings. So recall the syntax. First we have our sequence. We have an open and closed bracket, and inside we can specify up to 3 arguments: start, end, and step. And we know that start is the index at which the slice starts. It's inclusive, which means the element that's located at the start index will be included in the final slice. Start is also optional, and if omitted, defaults to 0. Next we have end, and end is the index at which the slice ends. It's exclusive, meaning that the element located at the end index will not be included in the final slice. End is also optional, and if omitted, defaults to the length of the sequence. Lastly, we have step, and step is the number of elements to skip between each selected element. It's also optional, and if omitted, defaults to 1. So we'll create a variable called greeting and assign it to the string hey you with an exclamation mark. And then under, we have a comment that details all of the indexes of each character. So let's go ahead and create a slicing expression that grabs a portion or a subset of this string. And that subset will only contain the characters H, E, Y. So let's go ahead and create a comment, and we'll say go of the subset is a string that has H, E, Y. So let's think about what our start index should be. So we know that start index is inclusive. So whatever element is located at the start index will be included in the final slice. So we want H in the final slice, and we see that H is at index 0. So that's a good choice to start our slice. And that's exactly how we'll be able to get H in the final slice. So for our end index, we know that n is exclusive. So the element located at the end index will not be included in the final slice. So we want y to be included in the final slice. And we see that y is located at index 2. So we know that if we were to choose 2 as the end index, then y would not be included in the final slice. So a better option would be to use index 3 as the end index, because we know that the character at index 3 is not going to be included in the final slice. So that's going to allow us to get h, e, and y. So let's go ahead and make n 3. Next, let's go ahead and create our slicing expression. So we'll start off with our sequence, which is greeting in this case. We have our open and close bracket. We know that the start index is 0 and the end index is 3. And we are not going to include the step argument, so we're going to omit it because we don't want to skip any elements. We want h, e, and y. So let's go ahead and print this out. I'll also include a string here so we can see the slice that we're getting or the subset that we're getting. So let's go ahead and run this. And as you can see, we get h, e, and y. So we can actually rewrite this expression in another way. So we know that if we omit the start index, it will default to 0. So there's no need to explicitly write 0 as the start index. And that's how this would look. So let's go ahead and run this. And as you can see, we get the exact same thing. So let's go ahead and go over another example. And in this example, let's get a subset of the string that has the characters E, Y, space, YOU, and the exclamation mark. So let's go ahead and create a comment, and we'll say go of the subset is basically this string here. So let's go ahead and create our slicing expression. We'll start off with our sequence, greeting. We have our open and close bracket. So we know that we want E to be included in the slice, and we know that the start index is inclusive. So we see here that E is located at index 1. So we can use 1 as our start index. And we also know that we want the exclamation mark to be included in the final slice. And another way to look at this is we basically want, starting from E, the rest of the characters in the string. So we can do this if we set the end index to be equal to the length of the sequence. So let's go ahead and create a variable called length, and we'll assign it to the length of the sequence. And the length of the sequence is 8. So we can go ahead and add length here as the end index. So let's see why this works. So we're basically creating a subset starting from index 1 all the way up to, but not including, the element at index 8. So if we look here, we're going to start at index 1 and we're going to include E. Then we're going to go ahead and take all of these characters up until we get to index 8, because we're not going to include what's at index 8. And if you look closely, this string doesn't even have an index 8. So this works perfectly. And that's how we're able to include the exclamation mark in the final slice. So let's go ahead and print this out. And then let's run our code. I think I made some type of spelling mistake. Oh, looks like this should actually be greeting since that's our sequence. So let's go ahead and run this again. And as you can see, we get EY space YOU exclamation mark. And we can actually rewrite this expression. So instead of putting the variable length, we could actually just put this expression here. So let's go ahead and run this again. And we get the same thing. So we can actually clean this up a little bit more. So we know that the end index is optional. And if we don't include it, it defaults to the length of the sequence. So we actually don't even have to take the length. By doing this here, we can just omit it completely and it'll default to the length by itself. So let's go ahead and run this again. And as you can see, we get the exact same result. So let's see another example. And let's create a subset that's going to give us the entire string. So let's go ahead and create a comment. And it'll say go of the subset. It looks like I actually misspelled this. So let's fix that quickly. So the goal of this subset will be a string that has all of the characters from the original string. Hey you with an exclamation mark. So let's go ahead and create our slicing expression. So we know that we want H to be included in the final slice. And we see that H is at index 0. So go ahead and have 0 as our start index. And we know that we want the exclamation mark. Or in other words, we want the rest of the characters in the string. So we can actually just omit the end index. So let's go ahead and print this out. Let's go ahead and run this. And as you can see, we get the entire string. And we can actually rewrite this to omit the start index, because we know that if we omit the start index, it's going to default to 0. So in this case here, the start index defaults to 0 and the end index defaults to the length of the string. So let's go ahead and run this. And as you can see, we get the same string as before. So let's go over another example. Let's create a comment. We'll say the goal of the subset. And this time, let's make sure our subset only has the characters E and Y. So we'll create our slicing expression. And if we want E, we know that that is located at index 1. So that will be our start index. And we know that we want Y to be included in the final slice. And we know that Y is located at index 2. So that means we should end the slice at index 3. So let's go ahead and add 3 as the end index. Let's go ahead and print this out. And let's run this. And as you can see, we get E and Y. Let's go over another example. And for this subset, let's say we want to get Y, O, and U. We'll create our slicing expression. And if we want Y, we see that Y is located at index 4. So 4 will be our start index. And if we want to end at U, which we see is located at index 6, then we should end the slice at index 7. So let's include 7 as the end index. And let's go ahead and print this out. Let's run this. And as you can see, we get Y, O, and U. So we can also use negative indexing with slicing. So let's go ahead and see that in action. So let's say the goal of this subset. And let's do EY again. So let's start off with our slicing expression. And let's see how we can get E using negative indexing. So we know that negative indexing starts from the end. So here we have -1, -2, -3, -4, -5, -6, and -7. So -7 will be our start index. And we know that y is located at -6. So if we want y to be included in the slice, then we should end the slice at -5. So let's go ahead and add -5 as the end index. And let's go ahead and run this. And as you can see, we get EY. Next, let's go ahead and do another example using negative indexing. And this time we're going to get the string U. So we'll start off by creating our slicing expression. And let's see where Y is. So again, this is -1, -2, -3, and -4. So we want to start the slice at -4. And we know we want the slice to end and include U. So starting again, the exclamation mark is -1 and U is at -2. So if we want U to be included in the final slice, then we should end the slice at -1. So let's go ahead and add -1 as the end index. And let's go ahead and print this out. And let's run our code. And as you can see, we get U. So we can also combine zero-based indexing and negative indexing to get a subset of a string. So let's see that in action. So let's say we want to get a subset, and let's also do U again. So let's go ahead and create our slicing expression. And we know that we can access Y in one of two ways. We can use positive indexes or negative indexes. So let's start off by using a positive index. So we see that Y is located at index 4. So we'll use 4 as our start index. Now we know that we want to include U to be in the final slice. So let's use negative indexing for this one. So if we want U to be included in the final slice, then we should use -1 as the end index. And that's how we'll be able to get U in the final slice. So I'll go ahead and add -1 as the end index. And let's go ahead and print this out. And let's run our code. And as you can see, we get U. So we can use positive indexing, negative indexing, or a combination of both to get subset of strings. So let's go ahead and see some examples using the step argument. So let's create a slicing expression that's going to give us back the entire string. So we'll start off with our sequence, which is greeting. We'll start off at 0 as the start index, so we can include the first character, which is H, and we know that we want the rest of the characters in the sequence. So we can make the end index the length of the sequence, which is just greeting. And for our step argument, we'll do 2. And since we're doing 2, this means that we are going to get every second element. So let's go ahead and run this. So as you can see, we get H, Y, Y, and U. And let's compare this with our original sequence. So we know that starting from 0 and going all the way to the length of the sequence, that's going to give us the entire string. And because the step is 2, we're basically saying we want every second element. So first we get H, then we skip E, then we get Y. Then we skip the space, then we get Y. Then we skip the O, and then we get U. And then we skip the exclamation mark. And because there aren't any more characters in the sequence, that's essentially it. And we're left with H, Y, Y, U. So let's see what would happen if we make step 3. So let's update this. And let's run this. And as you can see, we get H, space, and U. So let's go ahead and compare this with the original string. So here we take H, then we skip E and Y and include the space. Then we skip Y, O, and we include the U. Then we skip the exclamation mark. And since the string has no more characters, that essentially concludes our slice. And our subset only contains H, space, and U. So step is great if you want to skip elements that are going to be included in your slice. So if we specify a step of 2, then we get every second element. If we specify a step of 3, then we get every third element, so on and so forth. So that essentially concludes slicing with strings.